Chapter 9 deals with rational expressions, and this is when factoring is coming out in full force. So I've said it earlier in the year, if you have not gotten factoring down, now is definitely the time to get it down. So if you don't know how to factor, please make some time out and come and see me, and we'll hammer that out. So let's take a look at number 1 here. We're going to just divide this. I have a monomial in the numerator and a monomial in the denominator, which means I can just divide out common factors. So taking a look at 4 over 18, I can just divide out a 2 from each of those, and that would leave me 2 in the numerator and 9 in the denominator. Now I'm going to look at the a's, and we did this earlier in chapter 5, but just to remind you, I'm going to take out the 2 a's here and 2 of the a's here. That leaves me with a cubed in the denominator. And over here, taking away 2 of these b's and 2 of these b's, that leaves me b in the numerator. So when all is said and done, I have 2b or not to be. That's the question. And then in the denominator, I have 9a cubed. Oh, if I had another example here, I did not. All right, here's number 2. Now, one rule that you may or may not remember with fractions is if you multiply fractions, so that's what rational expressions are, it's just a fraction. So if you multiply 2 rational expressions together, you would multiply the numerators and multiply the denominators. And so really, if I'm multiplying this, I can kind of just extend this, and it's this times this and this times this. So we can go ahead and just divide out common factors because it's all multiplication, and because in this particular example it's just one term that we're multiplying by one term. Same with the denominator. So I'm going to divide out common factors again, but now I can kind of go across here. So you cannot do that if this is an equal sign, by the way. So this is multiplication, this is multiplication. Kind of look like a division sign there, so I'm just going to change that. So I'm going to start with the numbers. So the 2 can divide out with the 4, and the 3 can divide out with the 6, and I can actually divide the 2's out. Then I'm going to look for a's in the numerator and denominator. I see a squared here. I'm going to divide out both of those a's along with 2 of these a's, and I'm left with an a. With the b's, I have 3 right here. I'm going to take 3 away from here. I have b squared, and then I'm just going to multiply everything that's left over in the numerator. So what I have left in the numerator is b squared, and in the denominator I have a times c squared. And there's nothing else I can reduce there. Another thing that you could do is multiply everything out first in the numerator, multiply everything out in the denominator, and then divide out your common terms from there. It's just whatever you prefer. I prefer this way because it saves a few steps. So let me show you this for example. So I have a trinomial divided by a trinomial. Now we have seen, for example, a trinomial or a polynomial divided by a binomial, and we used synthetic division to divide that out. Here, we're going to factor everything first. So again, I cannot stress enough how important it is to be able to factor and factor quickly, and that will give you, that will really be good for you in the long run with this unit. And so when I'm looking in the numerator here, I'm going to go ahead and factor this trinomial. This should be like, oh, I know how to factor this by now. And again, if it's not, come and see me and we'll work on it some more. But here's the factors for the trinomials. And now I'm going to look for common factors. Now, when we're talking about binomial factors, again, that's 2 terms. So I have a binomial times a binomial right here. When we're talking about binomial factors, or even trinomials, it's an all or nothing deal. So I can either divide out the entire binomial or nothing. You cannot just divide out part of it. And so I'm going to divide out the x plus 1. I'm going to hold the spot with a 1. And the x plus 1 here, I'm also going to hold the spot with the 1. Sometimes it just helps you remember, oh yeah, I still have a numerator. All right, so in the numerator here, I'm left with x minus 3. And in the denominator, I'm left with x minus 5. And there's nothing else I can simplify there. You absolutely positively cannot divide out the x's because they're attached with this minus sign here and here. They're part of a binomial. So now I'm just going to remind you how to divide fractions. Here's what you want to do. You want to keep, change, flip. All right, we're going to keep the first fraction. We're going to change the division to multiplication, and we're going to flip the second fraction. And then from here, we're back to multiplying. And so I can divide out the 3 with the 6, and I multiply whatever's left over. So 2 times 2 is 4. In the denominator, I just have 5. So you got to remember this. Keep, change, flip when you're dividing fractions. I was going to have you guys do this one on your own. However, I think I changed my mind about that. You're welcome. So when I have, so this is a really kind of, it looks kind of like, oh my goodness, what's going on here? But it's really not too bad. You just got to kind of take it apart. So I have x squared plus 7x plus 10 all over x plus 2 divided by, okay, so this is a division symbol right here. Really, so is this, and so is this. But in the end, we have one fraction divided by another fraction. So I'm just going to write it out like this first. Kind of helps us get a better visual of what's going on here. And now I'm going to remember what I did up there. We're going to keep, change, flip. All right, so I'm going to keep this one, x squared plus 7x plus 10 over x plus 2. I'm going to change division to multiplication, and I'm going to multiply by the reciprocal of the second fraction. And now I'm going to just factor anything I can. So there's really only two things to factor here. So I'm going to factor this numerator. This is a trinomial, and the factors would be x plus 5 times x plus 2. If you prefer to factor out using factor by grouping, you can certainly do that. And this is the difference of two perfect squares. So that is x plus 5 times x minus 5. And now I'm going to divide out anything I can. So I have the x plus 2 here. I can actually divide it out with either one of these, but not both. So I only have one x plus 2 in the denominator. I guess I'm just going to choose this one right here. Divide it out with this x plus 2. And I'm going to divide out the x plus 5 with the x plus 5 down here. And so what I have left is x plus 2 in the numerator and x minus 5 in the denominator. And we are going to be practicing with all of this in class. See you then.